Okay, we're in section 23 in the homework. I'll certainly go through each problem. The problems will get more difficult towards the end. In the beginning, though, they aren't so bad. You should be able to do the beginning ones pretty quickly. Towards the end, they do get difficult. If you do get exhausted, take a break, come back and finish it later. Thank you. And I'll just go to the whiteboard now then. Again, we're in the homework 23. So first one is, looking at it, says use the ratio test, determine the radius of convergence. So let's go through that. And certainly I'm going to write it down, limit. And the limit is n goes to infinity. And that's going to be a n plus 1, which is x to the n plus 1 over 2 to the n plus 1. And we're going to divide by an, which is multiplied by the reciprocal. That's 2 to the n over x to the n. And what do I want this thing for it to be convergent? I want it to be less than 1. Okay, so let's take a look at it, see if we can do that. And the first thing to do is limit n goes to infinity. And I got an absolute value here. I want it to be less than 1. And what do you get there? I guess you'd get x on top, right? And at the bottom, you'd get a 2. So that has nothing to do with n. So its limit is just simply the absolute value of x over 2. And that has to be less than 1. Now we're really back in math 119, solving an absolute value inequality. And what would this be? It would be x over 2 would be between 1 and minus 1. And we'd get there minus 2, x up to 2. The length of that interval, by the way, is 4 units. So its radius is 2. What did they say? Determine the radius of convergence. They did not say interval. So I got the radius right over here. All right, this one over here, a little different. This one says find the interval of convergence. So let's put it down, limit. Again, I want to warn you over here. When I'm doing homework, it's sort of like, I write down this scratchy little work over here. It's the blue area the way it should be presented though. All right, so certainly scratchy work is fine, but your intent at some point is to get towards what's written in the blue area. All right, let's do this one over here. Limit n goes to infinity. Let's see the absolute value of x to the n plus 1 over the root of n plus 1 times 9 to the n plus 1. Now I'm going to divide by an, which is like multiplying by its reciprocal. So it's going to be root n, 9 to the n over x to the n. And this should be less than 1. All right, let's see if we can simplify that. And what would you get there? The x, you just get an x. And then I get a 9 in the bottom. And then I get this root problem over here, which is n plus 1. What's that limit? Well, it's pretty simple. It's the root of that, n over n plus 1. So it's really just the root of 1. So I get the absolute value of x over 9. I'll write that down for you. And what would this be? Well, back in 119 again. What's the x going to be? It's going to be between 9 and minus 9. Now, certainly, I know the radius of this thing is 9, but they asked for the interval. Now, what does that demand from me? I got to plug it in, and I got to test them out. So if you do this, what do you get? You would get the sum. I'm doing minus 9 first for a reason. And you get to up to infinity. And that would be minus 9 to the nth power over root n, 9 to the nth power. And what would this give us? That would give us this. And this is convergent by the alternating series test. So it's convergent. I'll just simply say by AST. So I'll include it. Let's do the 9. And if you did the 9, that's going to be n equals 1 to infinity. It's going to be 9 to the n. Again, we're plugging in the original expression, root n and 9 to the n. And what does this give us? It gives us over here. And that's 1 over root n. This is the divergent P series. So we found it. And what's going to be? Our interval of convergence is going to be from minus 9 up to 9, not inclusive. Again, my recommendation, look at the key. Let's take a look at that. And we got that right over here. Okay, so wasn't bad. Let's do the next one. This one, ratio test determine the radius of convergence. I actually prefer the radius over the interval because it's easier. Let's write this down. Limit n goes to infinity. It's going to be x. Well, 2 times n plus 1 is 2n plus 2 over 5 to the n plus 1. That's an, right? And I'm going to divide by, I'm sorry, that's an plus 1. I'm going to divide by an, which multiplied by its reciprocal, 5n over x to the 2n. This should be less than 1. Limit n goes to infinity. Absolute value, that would be x squared. And you get a 5 in the bottom, less than 1. By the way, it's nothing to do with n now. The n's gone. So what I get, it's the absolute value of x squared over 5. Well, that's just simply x squared over 5 less than 1. And again, I'm really back in 119 solving a quadratic inequality. And this is a rather easy one to do. But again, if you're not finding it easy, come by during office hours and we can review some of the material that you learned in Math 119. All right. Whoops, sorry about that. I didn't mean to put the square down there. You know what? Maybe I went too fast with that. Let me erase this over here. So the x squared less than 5, multiply both sides by 5, which means x is between root 5 and minus root 5. What's the length of that interval? 2 root 5s. What's its radius? Half that. So the radius is root 5. All right, let's go to the next page. Let's see how we did. And yep, they got it over here. All right, let's look at this one over here. And again, it's an interval problem. It's more difficult, but I can still do this limit, right? So I'll write that down for you. The limit as n goes to infinity, n plus 1, x minus 4 to the n plus 1 over n, x minus 4, n, and that should be less than 1. And let's do it. And when you get over here, taking that limit, well, let me simplify it first. What do you get? Limit n goes to infinity, absolute value n plus 1 over n times that x minus 4, we've just reduced to x minus 4. And the limit of that n plus 1 over n is just 1. So this guy turns out to be the absolute value of x minus 4 less than 1. What does that mean? Well, again, I'm back in Math 119. It means this. I'll add 4 to all sides. I'll give you 5. And this would give you, if I'm adding 4, would give you 3. Again, I gotta read it interval. So here's my trouble. I actually have to go back up here and plug it in. And when I'm plugging in, I'm going to plug in 3 first. So we got 3 to 5, right? Let me make sure I did say that over there. Yeah, 3 to 5. Let's plug it in. Let's try the 3 first. N equals 1 to infinity. N, and what we get over there? Well, 3 minus 1 is minus 1 to the n. This is clearly a divergent. It's divergent. This is divergent. Now, if you did 5, what do you get? N equals 1 to infinity. N, and 5 minus 4 is 1, so it's 1 to the n. This is also clearly divergent. So what's my interval? 3 to 5. All right, let's look at our key, and let's see how we're doing. And we're doing okay. Let's go to the next page. And again, the interval. So a little more challenging. Let's write this down. Limit n goes to infinity. Absolute value. It's going to be 3x to the n plus 1 over n plus 1 times n over 3x. It should be less than 1. Let's just do that. And what do you get over there? Again, I get a little better with it. I realized I had the limit over there and simplified it. I would just get the absolute value of 3x. All right, not a bad limit to do. And then what do you get? Oh boy, I got to do that 119 material again, right? So it's going to be this. And x is going to be between minus 1/3 and 1/3. Again, I want to point out this says interval of convergence, right? So I gotta test the endpoints now. That's a 3. So let's take a look. What do you get over here? N equals 1 to infinity. Well, that would be minus 1 to the n over n. By the AST test, this is convergent. What's this one over here? I'll write it down for you. Oh, by the way, I'll put the equal sign there because it does include it. We did the DST in our head, by the way, infinity. And this would give me 1 over n, which is divergent. You should know that's divergent harmonic. So what's the interval over here? Minus 1/3 up to 1/3. All right, mistakes happen. That's why we provide keys for you and work. We provide work as well. Work that's neatly typed up, by the way. Okay, we got that right. Next one. So again, interval convergence, I'm looking at it and I'm going to write down limit and goes to infinity, x to the n plus 1. And this is going to be n plus 1 factorial raised to the 8th power times n factorial to the 8th power over x to the n. And this is supposed to be less than 1. So what do we get over here? We get the absolute value. Let me write this over here. A little more difficult because we have factorials and powers. So it's x. And then what do you get? Well, if you looked at it, and again, what you're getting, I want this on the side for you. You're getting n factorial to the 8th power, and you're getting n plus 1 factorial to the 8th power. Not that I want to write everything down, by the way, but I hope you realize that it's really just n factorial over n plus 1 factorial raised to the 8th power. All right, what would that give us? Well, thinking about it, I mean, you get a lot of cancellations there, right? So you just get 1 over n. I'm sorry, 1 over n plus 1 to the 8th. All right, let's take a look at it. What would you get over here? Well, I hope you realize that as we go towards infinity, this is going to go towards 0, and 0 is always less than 1. So the interval of convergence will be all real numbers. There's no x that wouldn't work in that problem. All right, when I say no x, no finite x. So let's take a look at it. It says by ratio test series converges, blah, blah, blah. Here the ratio test of zeros for all x, ratio convergence, infinity. Series converges for absolutely for all x. And that's what I wrote over here. Okay, that was pretty good. Wasn't bad. Let's go to number 7. Interval, again, another interval problem. Let's write it down. And I'm doing a little bit of work. Again, I've already typed it up for you. We're just talking about what I would do before I type it up. Maybe a lot of scratch work on paper, and then I type it up. All right, so I'm sorry, not x goes to infinity, it's n goes to infinity, right? So let me go backwards. N goes to infinity. And you're going to get minus 3 to the n plus 1 times x minus 4 to the n plus 1 over n plus 1 squared times, and again, I'm getting better at this because I've done so many in front of you, minus 3 to the n. The problem with getting better is sometimes you get really sloppy, and it's got to be less than 1. Let's simplify. Oh boy, we got a lot of stuff here, don't we? So I'm definitely seeing, maybe I went too crazy with this thing in here. I'm definitely seeing n over n plus 1 squared. We'll do that later. And then the minus 3 to the first power. I'll do that later. And then I see x minus 4. All right, what's that limit produce? 3 times the absolute value of x minus 4. All right, that's not so bad. Let's keep going. And I'm going to divide through by 3. And this would be minus 1/3 x minus 4 1/3. And then I would add 4 to all sides. So you get 4 minus 1/3. I'll simplify that later. And 4 plus 1/3. What do you get over there? Well, let's see. That would be 12 minus 1, 11/3 x. And that would be 12 13/3. All right, now certainly, I make sure you understand the question of interval convergence. So I got to test this out, and I'm testing at 11/3, right? And again, the series is up here. All right, so I'll write this down. So series, and again, if you can't remember, n equals 1, off to infinity, minus 3 I'm testing this one first. And what would you get? 11 thirds minus 4. That's an n, I'm sorry. 11 thirds minus 4. So it's 11 thirds minus 12 thirds, which is minus 1/3 to the nth power over n squared. And what would that give you? Well, that actually simplifies pretty nicely. It simplifies to n equals 1 to infinity. And the top would just simplify to, let's see, 1 to the n, right? Which is just simply 1 over n squared. This is a convergent P series. So this gets included. All right, let's do the 13 thirds. I'll do it over here. It's going to be the sum n equals 1 to infinity minus 3 to the n. And then you're going to get what? You're doing 13 thirds. Well, 13 thirds minus 12 thirds, because minus 4 is 12 thirds, is going to be 1/3, right? To the nth power over n squared. What does this turn out to be? It's n equals 1 to infinity minus 1 to the n now over n squared, which is, it's still convergent. I mean, it's convergent by the AST test. So this is also convergent. All right. So what do you get over here? We got 2 endpoints included. Let's put it down. Our interval is going to be from 11 thirds up to and including 13 thirds. All right, let's look at our answer. And we're seeing that right over here. And again, you're seeing work that's typed up for a reason, by the way. We'd like you to look at that work. We'd like you to aim towards that work as well. All right, interval again. It's really exhausting, but you're really doing the same thing over again. They just vary the problems a little bit. And it could put someone to sleep, actually. And especially if you're not engaged in the subject area. So this is going to be 9 to the n plus 1 over 7 times n plus 1. Let's keep going. Times x plus 4 to the n plus 1. And then I got to multiply by the reciprocal. And that's going to be 9 to the n. X plus 4 to the n, we'll simplify that later, and 7n. So what do I notice? A lot of things happen here. Oh, by the way, less than 1. A lot of things are happening. And certainly the 9, you get, there's going to be 9 then, right? Because n plus 1, n factors cancel off with 1. And you get x plus 4 on top. And then you get a 7. They cancel. And then you get times n over n plus 1. And take the limit now. What's the limit? Well, the limit as n goes to infinity is going to be the absolute value of 9. Whoops. I think I went too quickly there. The absolute value of 9, which is 9, and the absolute of x plus 4 is the absolute of x plus 4, less than 1. So let's see if we can do this. And I'm going to do this a little different this time. I'm going to say 9x plus 36 is between 1 and minus 1. And that means 9x minus 37. And let's see, that would be minus 35, right? And again, I'm not beyond making mistakes. This is minus 37 ninths. And this is minus 35 ninths. So I'm going to look at it and say, what was the question? It's the interval business. So I really have to be careful here. And so what do you mean you're going to be careful? I got to plug it in here. And what would you get? Well, let's try this one first. All right, what are you going to get? You're going to get the sum n equals 1 to infinity, 9 to the n, and then, minus 37 ninths plus 4, that's 36 ninths, which would be minus 1 ninth over 7n. And I have to work on it. I mean, there's no way I could just say, oh, this is this. I'm going to put some work down. That's going to be minus 1 to the n over 7n. This is convergent. Just the AST test alone would tell us that's alternating series, by the way. Let's try this one, see what we come up with. And what do you get? Let's write it down. This is n equals 1 to infinity. You would get 9 to the n. And minus 35 ninths plus 36 ninths is 1 ninth over 7n. And what do you get over here? Whoops, sorry about that. This would be the sum n equals 1. By the way, this gets included. Sorry, I should have put that down before, to infinity. And this would be 1 to the n, which is just 1 over 7n, divergent. related to the harmonic series. So I got my interval. My interval is going to be from minus 37/9 up to minus 35/9, not included. Now, again, mistakes happen. This is why we write keys for you and work. So let's see if we did that. Yep, seen it right there. All right, let's go to number 9. Get closer to the end of the problem set. And let's see if we can do it. And it's, again, the interval problem. So let's write this down. Limit n goes to infinity. That's an infinity over there. Absolute value, e n plus 1 times x minus 3 over n plus 1. Let's see, we're dividing by an now, which is e to the n, x minus 3 to the n. This should be less than 1. What do you give your limit? N goes to infinity. Absolute value e. And then you get x minus 3. And that's the absolute value, less than 1. Wow, that's an easy limit. You get e, x minus 3, less than 1. Absolute value, by the way, which means it's between those two numbers, minus 1 and 1. I'm going to divide through by e. And then I'm going to add 3 to all sides. You get 3 minus 1 over e. And then you get 3 plus 1 over e. Let's take a look. They want interval, right? So I got to plug it in. Well, let's take this guy here and plug it in. What do you get? N equals 12 to infinity. And it's going to be e to the n. And if I plug them, what would I get? I would get minus 1 over e to the nth power. I'm going to keep simplifying that. And what would that give you? N equals 12 to infinity. This would just give you minus 1 to the nth power, which is clearly divergent. Just look at the limit, the nth term. So what's next up? Let's do this one over here. And what do you get over there? Sum n equals 12 to infinity. We're looking at the upper limit now. And you would get e to the n. And that would be, let's see, 3 plus, oh, just 1 over e to the n. And what does that give you? Sum n equals 12 to infinity of the number 1, also divergent. All right. So I got my interval. The interval is going to be 3 minus 1 over e, comma, 3 plus 1 over e. All right. Again, my recommendation, please look at the key. Please look at the work if necessary. And I'm seeing that. The only difference, I write e to the minus 1. What am I writing? 1 over e instead. Okay. Now this one, there's words in it, and certainly there's more words. So they're telling me that I should use this equation they're giving me. And this is a geometric series, by the way. And maybe I should write that down. So a geometric series would be, if I wrote that down, they're saying that u to the 0, what's 1 plus u plus u squared plus, what's a geometric series? That equals 1 over 1 minus u, provided the u, right? This goes back to your mth120 days. The absolute value of u is 1, which means the u is between minus 1 and 1. So what they're asking to do is they say, well, use this to expand this guy over here. So I'm going to write this down so it looks more like that guy. What I mean by that, I want it to look like this guy over here. All right, let's write that down. So I'm going to write down 9 times 1. Well, I got that part. And then I'm going to write down 1 minus all right, let's write this down now. All right. It's going to be 9 times. I'm using this formula up here to write this over again. So what's going to be? Wow, it's going to be 1 plus minus 4x to the first power plus minus 4x to the second power plus yada, yada, yada. All right. Now what do I know about that? I know the absolute value of that, that minus 4x thing. I'll write this over here, which would be 4x is less than 1. All right. Now, what does that mean to me? Well, the x would have to be between 1/4 and minus 1/4 for that to be true. All right. Now, they want me to write a power series down. And I sort of did, but I think our gold standard is, can we write it so it looks like a, a summation problem? And let's write this down. And I'm going to put 9 here times n equals 0 to infinity. And I'll write this over here, minus 4x to the n. I'm going to write a little bit differently. Look at the key later. Minus 4 to the n times x to the n. Understanding x is between 1/4 and minus 1/4. All right, let's look at the answer key. Let's see how we did. And they got it written over here. All right, and they got this written over here as well, which means I got the minus 1/4 to 1/4, which I wrote down too. Let me make sure I did that. Minus 9, 4 minus 4 to n. Bingo, got it. All right. Okay, this one, it says apply integration now. And, integrations are always difficult, but I'm hoping it's not going to be difficult on this thing. So as soon as it says apply the integration for this one over here, and I'm just going to do it. I'm going to just, excuse me 1 second. I made a mistake there. So I'm going to integrate. So I'm going to integrate the left side. I'll worry about their question later, by the way. And whoops, I didn't mean to put a plus sign there. I was thinking about and, I'm going to do something else. And I'm going to integrate the right side. All right, integration is always tough. Let's take a look. So what do you get? The natural log, right? By the way, this is only true for x between minus 1 and 1. So I know it's always going to be, if it's between minus 1 and 1, I know that 1 over 1 plus x is always going to be a positive number. So I'm not going to use the absolute value symbol. So I'm going to say natural log of 1 plus x equals, well, there's going to be a constant integration, and I'm going to put it on the right side. And I'm going to say c plus, there's a constant integration somewhere. And let's write this down. And I have to be careful. It's going to be x minus x squared over 2 plus x cubed over 3 minus x4 over 4, yada, yada, yada. I think you get the idea. Now someone says, I wonder what the C is. I do too. I wonder what it is. So I got to pick some number that makes this a true statement. And the number that makes this a true statement that's easy for me to deal with, I'm going to just simply say let x equals 0. Is it on the interval between minus 1 and 1? It sure is. So what do you get? Natural log. Well, if x is 0, you get 1, right? And what happens to all those terms on the other side? They all disappear. So now I know what the C is. And what's the C? The C has to be 0. So now I know the natural log of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x4 over 4. Now, granted, this is a yada, yada, yada. I'm not sure what their question is, but I want to look at it. And what they want is an expansion for 4 times that. Well, I'm going to write that down now. So 4 times this is going to be 4 times the other side, which is the sum. And what's that sum? I didn't mean to put that. The sum, well, let me write this as a 1 over here, makes it easier for me. And let's take a look. You got 1, 2, 3. So I'm going to say n equals 1 to infinity. And I'm going to say x to the n. Let's see, 1, 2, 3, 4. Yep. And what's the bottom going to be? N. And then I got it alternating, right? And how's it starting out as positive? So it's going to be n plus 1. All right. I think I'm done. I'm just going to neaten up a little bit. You know what? I'm going to pull a 4 on the inside. N equals 1 to infinity minus 1 to the n plus 1 times 4 x to the n over n. All right, let's take a look and see what they got. And I'm seeing it right over here. Again, I want to point out there is a lot of work over there for you to look at if you're interested in looking at it. So -1 to the n plus 1. I got the 4. I got x to the n. I got an n. They start at 1 to 0. Yep. And again, we're still stating the x between -1 and 1 there. All right. I got to be honest with 15. 15 is tricky. There's no doubt about it. So, I'm kind of looking at it, and I would like to, be able to do it. But, what are they telling me over here? They're telling me this. And someone says, didn't we just do that? We did. We just did that. All right. So, someone's going to say, well, what do you want to do now? I mean, there's many things I could do. But, one of the things I could do is, I see this thing. They want to apply the integration to this thing over here. And I'm kind of looking at it. And I think I'm going to rewrite it a little bit. And so I'm going to write it down as ln 1 plus 5x. I'm just making a substitution, by the way. What would you get over here? And again, maybe this is going to be too difficult. Maybe I shouldn't be doing this. And what do you get over there? Well, 5x squared over 2. I'm just simply copying. 5x cubed over 3 minus 5x 4 over 4 plus yada, yada, yada. Well, let's write this down now. What do you get over here? N equals 1 to infinity minus 1, n plus 1, 5x to the n over n. Now, by the way, someone says, why would you have done that? I don't know. I just saw it. I saw the 5x plus 1. But then I got another trouble in my hand. And someone says, what's the trouble? They say apply integration to this problem. I don't know if I can do that. Let's see if we can do that. I'll put this over here. Put this over here. Well, I'm going to erase the sum formula because I'll be honest with you, integrating a sum formula just doesn't look right to me. It can be done. I'm not saying it can't be done. It just doesn't look right. And I'll just put a dx over here. All right. So, wow, that's going to be a lot of work, isn't it? So I just want to remind you that I think I've done this problem in math probably the beginning of the semester, that we knew the anti-riff of natural log of u du was going to be, let's see, we'll check it, u ln u minus u. All right, now you may not remember. I'm going to check it. So what would you get? You would get u times 1 over u plus 1 times ln u minus 1. Well, 1 minus 1 is none, so we do get ln u. So this works out nicely. So what I want to do is I want to see, can I integrate this guy, which is ln 1 plus 5x. Like, I guess I have to do u substitution, right? So u would be what? 1 plus 5x, and du would be 5 dx, or 1/5 of a du would equal dx. So let me write that down for you. And again, we'll go back to the problem a little bit later, because I did say integrate, so I'm trying to integrate. So let's see, I guess you would get 1/5, right? ln u du. Wow. So what do you have there? 1/5 ln, right? What's the u? It's 1 plus 5x. Plus some constant integration, by the way. I'm not going to worry about that because there's two sides to integrate. I'll just keep it on one side. That's not so bad, right? Oh, I'm sorry. I made a mistake over there. I didn't put something else in. I got to do that now. And I just realized it. I got my eraser out. Minus 1. And u is 5x, right? 1 plus 5x. All right. I guess I should, oh, there's a C there too. All right, let me see if I can do that. And I'm going to write it down for you. I'm not saying it's not problematic. It is problematic. But let's write this down. So it's the left side is going to be 1/5 times the natural log of 1 plus 5x minus 1 plus 5x. Now let's do the other side. It's going to be 5x squared over 2. You know what? I want to put my constant down first. So it's going to be 5x squared over 2 minus 5 squared x cubed over, again, I just did this one 2 times 3, right? I'm going to just put a 1 over here. Let's do the next one. Plus 5 cubed x, that would be 4, right? 3 times 4. Minus, let's put another one down. That's going to be 5 to the 4 x5 over what? 4 times 5. Well, it's a really nice pattern, I think, but I'm not there yet. All right. By the way, I'm going to erase some of my side work. And the side work I'm going to erase over here is not really something we did in the beginning of the semester with the integration by parts. You may not be able to remember that, though. It happens. I can't remember a lot of things either. I'm going to multiply both sides by 5. All right. Now, when I do it, I'm going to write it down. If I multiply both sides by 5, I would get the natural log of 1 plus 5x minus 1 plus 5x. Now, 5 times a constant c is going to be another constant. I'm just going to call it C2 now. And this is going to be C1. I still don't know what it is, by the way. And then I'm going to do this next. It's going to be 5 squared x squared 1 times 2 minus, I'll get to the C later. Don't worry about that. 5 cubed x cubed 2 times 3 plus 5 4 x 4 3 times 4. I think you get the idea, right? Minus 5 5 x to the 5 over 4 times 5. All right, yada, yada, yada. All right, so it's just, could you figure out the C now? I think so. And what I would pick is an easy x. I'll put this over here. The x I would choose is 0. So if I did that, what would I get? Well, you would get the natural log of 1, which is none, and then you would get minus 1 here. So if you plug in x on this left side, you get minus 1. And what do you get on the other side? Well, you get C2. So what's the C then? It's minus 5. I'm sorry, it's minus 1. So I'm going to erase that C2 now and put the minus 1 in. And I don't want to keep writing this thing over and over again. So now the C2, right, this thing here is going to be minus 1. What was the question though? And so I don't even remember what the question was. It said, let this thing apply the integration to it, right? And by the way, they're giving me this interval over here. We knew about the interval anyway. So I did it. I applied my integration. I got everything done. All right. But you know what? They want me to, I guess they want me to come up with this. Right? And I'm sort of seeing it. So I'm going to write this over here. So I'm going to write down ln 1 plus 5x minus 5x. This is the big f of x, isn't it? Well, I hope you realize I got troubles, don't I? So what do I have? I have ln 1 plus 5x minus 1. Well, then that minus 1 on the other side is going to cancel. So what I left off with over here, I'll write down for you. 5 squared x squared, 1 times 2, minus 5 cubed x cubed, 2 times 3, plus 5 4 x 4, 3 times 4. So I'm going to, again, I don't even know what their question is yet. So I'm going to say f of x is equal to the natural log 1 plus 5x minus 5x is equal to the sum, right? And let's look at it. I'm going to say it has something to do with 5x. And let's look at the power first. So it looks like we're starting at 2, doesn't it? And going off to infinity. I'll clean this up later, by the way. Now, what's the bottom going to be? Well, it looks like there's an n here and then an n minus 1 here. And it alternates. It has an alternate between plus and minus. So I'm going to say minus 1 to the n. All right, I'm going to clean up a little bit. We'll get to their question later. You know what their question is. Maybe it has nothing to do with what we're doing over here. Oh boy, I clean up a little tiny bit. Mistakes happen too. And you're going to notice when you're doing homework, you're going to make a lot of mistakes. All right, let's just see if they ask for anything. Well, I kind of did what they said, but it says let this apply to integration known. So let's go next page. Well, I guess they got the formula for it just like we did. Now someone could say, oh, this one looks different. And you know what? Sometimes they do look different, and you have to resolve that issue. So let me point out, I'm going to grab this. I'm going to grab this. Let me try to grab it. Sorry about that. Get dizzy sometimes. I'm going to grab it. And I'm going to bring it to the other side. Whoa, boy. That's the formula I gave you, right? Let me paste the formula they've given you. This is going to happen to you, by the way, particularly if you ever become a teacher and you're looking at a grade, the student, someone said, oh, the student got it wrong because they wrote that down. It's really the same thing, right? It's really the same thing. I started at 2, so they started at 1. So I hope you realize if you start at 1, this is starting, n plus 1 would be starting at 2 then, right? So it's, let me just see if it's the same thing. 2, that would be 1 times 2. Yeah, same thing. These are identical. If you don't see that, my claim over here is expand them. And if you expand it, you can see term by term, they're identical. A lot of times that's what students have to do, expand things to get them to be identical. Now, I want to point out for a lot of students, this is considered to be tough. By the way, when I say it's tough, I get stuck too. Right? I get stuck and things get really, really difficult. I know I'm going in the wrong direction. All right, let me go to the next page. Let me do this one now. We just finished that one over there. Give me 1 second. Get my eraser out because I got a doohickey there I get rid of. And let's take a look at this one over here. And what do they want to do? Find a power expansion, a power series expansion for this. So what I would do first is, I'm not going to integrate that because, that looks like a tough integration for me to do. I'm not saying it's impossible, by the way. I'm just saying I don't want to go near it. I want to do what they said to do, which basically what I'm doing is I'm looking at this. And I'm going to say this looks sort of like this. Whoops, I don't think I did a very good job there. Let me go backwards. It really doesn't look like that. I mean, it does look like that, but it doesn't, not what I want it to look like. Let me get my eraser out again. I hope you realize they're identical statements. All right, now, so why would you have done that? Because I have a nice expansion for this. And what's that going to be? 1 plus u squared plus yada, yada, yada. Well, let's write this down. 1 plus u squared plus u cubed. I think you get the idea. All right. I'm going to kind of simplify it though. And the way it looks kind of looks weird, right? So 1 minus x to the 5 plus x10 minus x15. Yada, yada, yada. All right. So what I'm going to claim over here is that 1 over 1 plus x5 dx is equal to, let's write this down, the integration 1 minus x5 plus x10 minus x15, yada, 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 dx. All right. It's trouble though. I'll tell you what the big trouble is. It's a c. Still got a c there. Plus, well, let's write this down. And the first term is going to be x. Next term is going to be x6 over 6. The next term is going to be x11 over 11. The next term is going to be x16 over 16, yada, yada, yada. And here comes our problem. I got to write this sum down now. So c plus the sum, I'm going to say they're all fractions. And then I'm going to say it's x raised to a power, and it's alternating. Now, again, I don't know what this thing is, but I'm looking at it. It looks like it's going up by 5. So I'm going to say something to do with 5n. All right, 5n. I'm going to say 5n minus 4. And I'm going to start n at 1. That would give me 1. 2 would give me, if I start at 1, it would give me 1. 2 would give me 6. 3 would give me 11. 4 would give me 6. That looks pretty good. That works good. So if I start it at 1, this would have to be n plus 1 then, because it's alternate plus and minus. Now what goes on the bottom now? Well, it looks like, let's see, 5n minus 4, just like the exponent. And where's it going off to infinity? All right. All right, let's look at the k. See how we did. And let's take a look. You know what? I didn't write the sum down. Oh, no, I did. I did write the sum down. It's right over here. Let me just make sure I got the right sum now. In other words, I'm going to copy it. C plus. Hey, they started at a different number, started at 0. But again, students might have to expand it to see that the same thing, but I'm going to make sure it is. And what would you get? 1, and then 2 would give you, 1 would give you 6. Yeah, same thing. Same thing. Again, you may have to expand these to see you get the same thing. All right. Let's see if we're done. No, we're not done. All right. This one's, oh, sorry about that. Let me get my, I'm going to look at this guy here now. All right. It says evaluate it. My one recommendation in evaluation is, you could certainly start adding things together, but I don't think that's the point of writing it down. The point of writing it down is maybe, maybe this thing's related to something what we just did. But let me just, that's 1 over 4 plus 2 over 4 squared plus 3 over 4 cubed plus yada, yada, yada. Now, I got to be honest with you. I don't know without having, all the problems that just came before me, I think I might struggle with this guy, but I'm thinking this might have something to do with the geometric. All right, something to do with it. So I'm going to write that down for you. Something to do with it. Let me write this over. So 1 minus u would be, what would that be? That would be 1 plus u plus u squared plus u cubed. You get the idea, right? And what I'm going to do is I'm going to differentiate this guy, right? So what would you get over there? Well, if you differentiate this guy, I'd be careful about it. It's 1 minus u to the minus 1. So it's going to be 1 over 1 minus u squared. Right? And what would that give me? Oh, by different, you would get 1 plus 2u plus 3u squared plus, well, then you get 4u cubed, right? Well, let's look at our problem over here. I think I'm seeing it. I think I see this. I'm thinking of seeing it. In that case, what would the u be? The u would have to be what number? 1/4. Let me write this down. So 1 over 1 minus 1/4 squared would equal 1 plus 2 over 4 plus 3 over 4 squared plus 4 over 4 cubed. All right. I hope you're seeing that what I want to say. Now, by the way, I'm not seeing, I don't think I'm seeing something here, right? So I'm not seeing exactly this, but I'm seeing, I'm seeing this part. Right? So I got to do something here to get to look exactly like that. Let me write this over here. And what I'm going to do, I want to get a quarter. So I'm going to have to subtract 3/4 from both sides. What would I get then? Well, 3/4 from 1 is 1/4, right? Plus 2. Wait a second. I'm not seeing that either. Let me erase that. I thought I saw something, but maybe not. Maybe I'm just tired. I want to see things that are not there. This happens to a lot of students. They see things that are not there. So I'm not seeing it. So what I'm going to do is I'm going to multiply both sides by 1/4 now. Oops, sorry about that. So I can multiply this side by 1/4. And I'm going to multiply this side by 1/4. Oh, I'm sorry. This goes on forever. That's not a good thing to do what I just did over there. Well, let's do this. 1/4 times 1. What's 1 minus 1/4? It's 3/4, right? We'll do that later. And what do you get in the right side? You get 1/4 plus 2 over 4 squared plus 3 over 4 cubed plus 4 over 4 to the 4th power. And that goes on forever. And again, I'm going to go back up here and do my little race because I shouldn't have done that circle thing there before. Am I seeing it? Let's see, 1, 2, 3, 4, 4 squared, 4 cubed. Yep, I'm seeing it. So I know the sum now. I'm not saying it's easy. I realize someone says, how could you have done that? Well, because we just did a bunch of problems. That's why. And let's write this down. I'm not saying I'm right, so I could be wrong. I got to do that now. What does this give me? 1 over 9/4, and this would be 4/9. All right, sum is 4/9. My recommendation, go to the next page and see it. It's right over here, 4/9. Now you might look at the work and say, oh, their work looks different. Your work, it's really not much different. All right. All right. Use a power series for this to find and differentiate to find power series of that. All right, let's write it down. All right, so I think I'm getting a little better here, right? So let me just tell you what I'm getting better at. I know that 1 over 1 minus u is 1 plus u squared plus, provided that the absolute value of u is less than 1. And I think we've hammered that across a number of times. And I'm going to write down the next one, which is 1 over 1 plus, I can't do that, I got to do minus, right? Put that down. So minus x4. And what's it going to be? 1 plus minus x4 plus minus x4 squared plus minus x4 cubed. You get the idea. All right. So what is this equal to? Let's write this down. 1 over 1 plus x4. I guess I should spend the other side. So it's going to be 1 minus x4 plus x8 plus, not plus, I'm sorry, minus x12. I think you get the idea. All right. Now, I got to read it. It says use the power series. I got the power series and differentiation. I guess they want me to differentiate this guy. And let me write this down for you. So this is going to be 1 plus x4 equals 1 minus x4 plus x8 minus x12 plus dot, dot, dot. I want to differentiate both sides with respect to x. So this side over here, and then this side. And let's see what we get. Whoops, I made a mistake already. And I'm tired. That's why I'm making mistakes. But I recognize I make a mistake because I look at it and say, that's crazy. Let's write that down. What do you get? Minus 1 times 1 plus x4 to the minus 2 times 4x cubed. Well, that's going to give me minus 4x cubed over 1 plus x4 squared. And what would that equal if I differentiate? You would get minus 4x cubed plus 8x7 minus 12x11 plus yada, yada, yada. Now, when I put the yada, yada, yada down, I hope it's predictable, right? Like the coefficients, they're alternating, 4, 8, 12. What would the next one be? 16. What are you doing? You're going up by 4. How about the powers? They're going up by 4 starting at 3. Now, someone says, well, why did they actually do that? They asked me, I did it. And now I'm going to multiply both sides by minus 1. So let's write that down. So we get 4x cubed over 1 plus x4 squared is going to equal 4x cubed minus 8x7 plus 12x11 minus yada, yada, yada. All right. So let's see what they said. Yeah, I guess we did it. And I guess I can write a sum down now for it. I'll be careful. And let's see. It's definitely got an x in it. And I look at the x, something to do with 4n. And if I start at 1, this should be 4n. I'll get the alternating pattern later. So 4n, 4n minus 1. And then what's the alternating pattern going to be? Minus 1 to the n plus 1. I'm going to clean up a little tiny bit. It's going to infinity. N equals 1 to infinity. Minus 1 to the n plus 1 times 4 to 4n times x to the 4n minus 1. All right, let's look at the next page, see if we got that. And again, I have to look at it. Minus 1 to the n plus 1, 4n minus 1, 1 to infinity. Yeah, we got it. All right. Again, the interval convergence of the thing, we know it's between plus or minus 1. All right. 16, it's a killer. It's the last killer we got, though. And certainly, I got to be honest with you. These are problematic problems. And I'm kind of looking at it, and all I can say is it's probably related to the past. It's probably related to the past. So I'm going to look at, I'm looking for, some geometric series over here because they tell me look for them. All right. So I'm going to do it. And I'm going to say this one, this one, this one. Let's see, it would be 0, 3, 6, and then it'd be 9, right? So I'm going to write that one down for you. So I got a series over here. So it's going to be, I'll write it down. Whoops, I didn't mean to do that. It's going to be 1. Did it again. 1 plus x over 14 cubed plus, I'm writing the red ones down, x over 14 cubed squared. This is 1. Again, I'm just writing these terms down over here. And the next one's going to be what? Plus x over 14 cubed plus yada, yada, yada. Well, this one doesn't look too bad to do. I'll write it down for you. I know the sum of that. All right. I know the sum of that. And I think I can write that down pretty quickly. 1 over 1 minus x over 14 cubed. All right. I got that guy done. And now I'm going to do another one. And I got to be careful. And someone says, why do you need to be careful? I just have to find something. So I'm going to go, let's see. And I got to really think about it now because I'm seeing the other guys. We're all negatives, right? So 1. And then that'll be 1 to 4 up 3. 4 to 7 up 3. Let me try that. All right. I don't know. Maybe it doesn't work. So I'll get my little blue pen out now. And I'm looking at these guys. All right, let me write down for you. And I know it's a subtraction, but I'm just going to still write the addition down. So it's going to be, whoops, I did that again, didn't I? You know what? I'll do it in blue. So this one over here, this is the red guy. Let me do the blue guy now. I don't know if I can do it. So it's x over 14 first power. By the way, I noticed subtraction. I'll do that later. And then x over 14 let's see, fourth power, right? And then x over 14. It's more difficult. I know that. 6th power. And that's x over 14. Let's see, 6. Did I do that right? 1. Oh, I'm not 6, it's 7. I'm sorry. Get my eraser out. Get real careful over here because you make one mistake, it never goes anywhere. They're going up by 3, right? So 1 to 4, 4 to 7, and then 7 to 10, right? And I think I know the pattern of this one over here, but again, I don't know the sum of it yet. And I'm gonna did I do that right? 1 to 4. Let me see, get the red ones right. 1, 3, 6, 9. And now I'm doing this one, right? 1, 4, 7, 10. Gone up by 3, right? Well, let me write this down. Let's see what happens. No, that's not doing it either, is it? Get my eraser out. I got to think again. And I got to think again and again and again. Got 1, 4, 7. They're going up by 3. I'm going to try that again. If you first fail, try again. Going up by 3, right? That would be 4, 7. Took out 3, right? That would be 4, took out 3, be 7 over here. Not what I want. Let me erase again. Anyway, I'm comfortable. Let me do the other ones though. I'm also going to erase this up here. I didn't do that. I just did the reds. The other one I'm going to erase this too. I'm going to start again. Let me make sure I did the red ones though. So I said 1. And then I did the x over 14 cubed. Got that covered. And then I did x. Let's see, I did 3. I did, and then I did 1. I did 3. I did 6 next. And then after 6, I did 9, which would be over here somewhere. And then I'm looking at the other ones. Let's take a look. 1, 2, 4, 5. 2, 4. 1. 1, 4, 7. Goes up by 3. 1, 4, 7 goes up by 3. Let's see. 1, 4, 7 goes up by 3. 2, 5. Let me try it. I'm going to try again. I'm going to write them both down this time. So, oh, I erased something, didn't I? Oh, no, I didn't. I didn't. Let me erase this over here, though. Oops. If this were an exam question, I would recommend, I'm not saying at Essex you're going to see an exam question like this, but certainly another school, like, do your best you can. Certainly, you might want to walk away at this point and simply say, I got part of it done, but not the full part of it. I'm gonna struggle with it. All right. So I'm gonna write down, and I'm gonna put it in a different color now. I'm still gonna go back to this. I'm gonna go up by 3. And I'm gonna write that down for you. So I know it's subtraction, but I'm still gonna write that as a sum. So x to the 14, whoops. And then the next one would be x to the 14 to the 4th. And the next one would be x to the 14, going up by 3, right? 7, yada, yada, yada. All right. What's the other one going to be? Well, let me put that down. And again, this is the green one. Let's do the blue one now. I'll write that down for you. What's that going to be? X over 14 squared plus, we're going to go to 5 then, right? Yeah, it's tough. I realize that. My next problem is really good. They are tough. And I hate doing problems that are always so simple that, you could probably sleepwalk through them. And let's see, 1, 5, 8. All right. Now, again, these two guys here, they're killers. All right. So I'm doing this over. Whoops, I didn't mean to do that. I'm looking at these two guys. And I'm wondering, what am I going to do with these two guys? So I'm going to look at them together instead. All right. Let me put that down for you. I'm looking at these together. All right. Let me see if I can do it. And the green one, I'm just going to factor out. X over 14. And what would you get? 1 plus x over 14 cubed plus x over 14 6. And the other one, I'm also going to factor out x over 14. What would you get over there? You get x over 14 plus x over 14 4 plus x over 14 7. By the way, I hope you know this goes on forever. Again, I'm looking at this now. One's going up by 3. The other one's also going up by 3. Let me think again. What am I missing? X, 1, 2. 1, 2. I think I know what I'm missing. Let me erase. So if you add these two together, you would get 1, 2. You'd be missing 3. Right, so I'm going to write these down what you're missing. If you add them together, what terms you're missing? 3 3, 4, 5, you're missing 6, 7, you're missing 9. So if I were to take the series, let me write this down for you, and I were to add together, x14 plus x over 14 squared plus x over 14 cubed plus yada, yada, yada. That series is pretty easy to do, actually. That series would produce x over 14, 1 minus x over 14. That's what that would produce. All right. But it's missing this. Would that be agreed? It's missing it. Well, I hope I'm not going into overtime here, but I could be. And I might have to stop the tape and come back. I don't want to do that, though. I think we went through the other problems really quickly. And this is the first one we're getting stuck on. It's the last one, too. And we get tired. We're missing 3, 6, 9. I'm going to remove it. So from this, what would I have to remove? I'd have to remove 3, 6, 9, which is related to this guy over here. So if I remove it, and again, it's missing that, it would be this sum over here. It would be that sum over there. It would be the sum of all these terms over here. But I got to remove something from it. And what to remove? I have to remove 3, 6, 9, so forth and so on. Three, 6, 9. Yeah, I can do it. So what's going to be? It's going to be, it's this guy over here now. So it's going to be, I'm removing 1 over 1 minus x 14 cubed. And minus 1 is plus 1. So that's what the sum of these guys is. And what I do is add all these things together. And what I'm doing over here, I have to take this original guy over here. I'll write it down for you. And subtract what I just did. Let's put it down. So it's minus x over 14, 1 minus x over 14, plus 1 over 1 minus x over 14 cubed, and then minus 1. Wow, this is going to be a lot of work here. Not that really. Let me see if we can put it down. So 2, can add these two together. 1 minus x over 14 cubed minus, I'm going to do this guy now. I'm going to multiply top by 14. So that's going to be 14. That's going to be x on top. And 14 minus x on bottom. And then minus 1. Boy, I got to do more work. I'm not saying I'm there yet. I'm going to multiply. This is cubed, right? Make sure I'm saying that right. Yeah. So it's going to be 2 times 14 cubed. 14 cubed minus x cubed minus x. 14 minus x minus 1. Let me see if I've done that. And I think I have. And I'm going to call it quits on that one. I found the sum. Let's go to the next page and see how good they did. And let's see how they did. 14 cubed minus x cubed. You know what? I'm going to go through it. The LCD is, let's write this down. 2 times 14 cubed. 14 cubed minus x cubed. This over here is going to be 14 minus x. And just give me a moment to do this. I have to figure it out. And I have to block something out over here. So 14 minus x, and then x minus 14. Let me be careful with this one. Give me a second, 1 second. 14. I'm going to factor the bottom. So it's going to be 14 cubed minus x cubed, 2 times 14 cubed, and then 14 times, that's going to be 14 cubed minus 14 cubed. I'm just multiplying it out, by the way. Minus 14 squared x minus 14x squared. All right, let's go next page, see if we got it. Did I get the 14 cubed? I did. 14 squared x, I did. 14x squared, I did. And 14 cubed minus x cubed bottom, I did. Okay, this is good. So I finally figured it out. But I'll be honest with you, it's tough. Right? It's not easy. And mileage may vary. And again, you may be a hard time following that. Granted, it's not easy to follow. Thank you for paying attention, though.